In this session, we are going to explore the internal execution of a Python code. But before going to this topic, we need to familiar with the various related terms with this topic, like source code, machine code, bytecode, compiler, virtual machine, and interpreter. Then we can be finally able to understand the internal execution of a Python code. This video will be divided into two parts. In this first part, we will cover up to compiler, while in the next video, we will cover rest of the topic. Our first term is source code. It is the programming statements written and understandable by the programmer. For example, if you write a program to add two integer number in any programming language like C, C++, Python, Java, then the statements written by you is nothing but the source code. Next is machine code. Our computers are able to understand only sequence of zeros and ones. It cannot able to figure out the source code, so we need to somehow convert the source code into the sequence of zeros and ones. This converted code is nothing but the machine code, which is understandable by the machine. Now coming to the bytecode, it is neither the source code nor the machine code. We can say it as the intermediate code. Now at this moment I think you have understood the meaning of source code and the machine code, but you don't have a clear idea about bytecode. For now, just note that bytecode is an intermediate code between the source code and machine code. We will discuss about it in our upcoming video. As I have mentioned that we need to translate the source code into machine code, and usually this is done by a compiler or by an interpreter. First of all, let's understand about the working of compiler. In case of compiler based language like C or C++, after writing the source code, it will get compiled by the compiler and it will generate the machine code. Now if this compiler is installed on machine 1, then this machine code is executable only on machine 1. It cannot be executed on different systems like machine 2 or machine 3. This basically makes these compiled based languages platform dependent. For better understanding, look at the animation. For example, you have written a program to print hello world using C programming language, which is a compiler based programming language. Now this compiler is going to take this source code and it will generate the machine code, which is understandable by the target machine only. Now this machine code will get executed by the processor and it will print the result. Now we can conclude that after compilation, the generated code can only be executed by the target machine. This compiled code cannot be executed on different systems. Now the question arises, why we need an interpreter if we already have a compiler? The real need of interpreter comes where compilers fails to satisfy some software development needs. We will understand this question by introducing you to the problem with compiler, and side by side we will also understand how interpreter deals with these problems. So first problem statement is compiler compiles the entire program at a time. The problem occurs with this feature of compiler when the source code is large in size. Then it might take hours to compile the source code, as compiler first compile the whole program, then it will execute them, which will significantly increase the compilation duration. Here interpreter comes handy because interpreters are designed to translate single instruction at a time and execute them immediately. Now we will understand this point by an analogy. For example, you have some balls in basket A and the task is to place these balls from basket A to basket B. Now there are basically two approaches to complete this task. We will observe the animation of each of these approach for 5 seconds and we will see which approach will transfer more number of balls in basket B. In the first approach, we will take one ball at a time and we will place it in basket B. Note that within 5 seconds, by this approach we have successfully placed 4 balls in basket B. In the next approach, we will first collect all the balls in another basket and then we will place these balls together in basket B. But note that in this approach, we have not successfully placed any single balls in basket B because we have so many balls. If we try to transfer all the balls at a time by taking the help of another basket, then it will spend the whole time duration, that is 5 seconds, for collecting the balls. If you try to match this analogy with our topic, then you will find these balls are nothing but the each statement of the source code. And basket A is the analyzing phase of that line and basket B is the execution phase of that line. And the first approach is equivalent to the working of interpreter. That is, it first analyzes each statement at a time and it will execute that line immediately. And the second approach is equivalent to the working of compiler, where it will first analyze the whole code at a time. And it will create a problem when our source code is large in size. I want to mention something at this point. From this above analogy, don't think that compiled-based languages are slower than the interpreted language. Because in reality, compiled-based languages are faster than the interpreted languages. Because in case of interpreted language, it will create an intermediate code before creating the machine code. Here actually we have a source code which is large in size. In this scenario, compiler fails to satisfy some software development needs. Our next problem statement is, in case of compiled language, it is harder to debug. As compiler compiles all the source code at a time, so we get to know about all the error together, which makes it harder to debug. But in case of interpreted language, it will execute one line of code, so it will raise an error after the compilation of inaccurate line, which makes it easy to debug. The next problem is, compiler-based programming languages are not portable. Compiler will translate the source code into machine code, and this machine code is only for the target machine. This machine code will not be executed on different systems. For example, if a program is executed on Windows system, it may not be executed on Linux or any other platform, so it is not portable. But in case of interpreter, it creates a bytecode or the intermediate code, which makes it portable. We will see how it makes the programming language portable in our next video. This is all for this video. In our next video, we will understand rest of the topic.